Hi, this is the question of today's discussion. J and L are two miscible liquids at all proportions. The plot is obtained that correlates variation of total pressure above liquid mixture is as shown. What is Henry's constant of liquid L as mole fraction of J is close to 1? Just look at a liquid mixture. There is a vapor above the liquid mixture. The total pressure is equal to Pj, the partial pressure of vapor from liquid J, and Pl, partial vapor pressure of vapor of liquid L. Total pressure of the liquid mixture is on y-axis, variation of mole fraction of J from 1 to 0 on x-axis. As we know, mole fraction of L plus mole fraction of J is equal to 1. When mole fraction of J is equal to 1, mole fraction of L is also equal to 0. And similarly, when mole fraction of J is equal to 0, mole fraction of L is also equal to 1. Now, for ideal solution, which follows Raoult's law, in this case for a mixture of two liquids L and J, we can write total vapor pressure is PL0 XL, that is a partial vapor pressure of liquid L, PJ0 and XJ, which is equal to total vapor pressure of liquid J. And P total now becomes equal to PL0 of XL can be written as 1 minus XJ plus PJ0 XJ. After rearranging, total pressure is equal to PL0 plus Pj0 minus PL0 times Xj. You can see that the total pressure changes linearly with mole fraction of J. And this is the line shows variation of total pressure with mole fraction of J, or in other words with a mole fraction of L. Now, if Xj is equal to 1, total pressure becomes equal to Pj0. When Xj is equal to 0, then it is only pure liquid and total pressure becomes equal to PL0. From the graph, we can decode that pure vapor pressures of J and L are 30 and 40, of course, in the units of mm of mercury. Above solution is showing positive deviation because the pressure measured is always more than as predicted by the Raoult's law. Therefore, for infinite dilute solution, we can apply Raoult's law and Henry's law, where solvent follows Raoult's law, solute follows Henry's law. As a question in particular asked for mole fraction of J is going to 1, then what is the value of Henry's constant for L? And here J is a solvent, L is a solute. Total pressure is pressure due to A and again pressure due to L. A being solvent, Raoult's law is applicable. L being solute, Henry's law is applicable, where KHL is Henry's constant. And this equation is written for mole fraction of J tends to 1. And again, replacing mole fraction of J with 1 minus mole fraction of L, we got final expression. P total is Pj0 plus mole fraction of L times Henry's constant of H of liquid L minus pure vapor pressure of J. And one more time, see, this is the relation how total pressure changes with mole fraction of liquid. So from XL0 to XL is equal to 1, the initial slope as Xj tends to 1 is given as tan theta is equal to 3. So here theta is equal to tan inverse of 3. That implies tan theta, the slope becomes equal to 3. So here slope is Henry's constant of liquid minus pure vapor pressure of J, that is equal to 3. From that, Henry's constant of liquid L as Xj tends to 1 becomes equal